In this video, we're going to take a look at all the processes that go on within Earth that cause things like volcanoes and earthquakes and plate tectonics, where the continents are actually moving around on the surface of the Earth. So let's go ahead and get started by taking a look at the layers of Earth. Now, you guys have heard of crust, mantle, core. Crust being the rocky layer on top. There's oceanic and continental crust. Mantle being the next layer down below, where it's hot and molten, and the core, which is the nice metal part in the middle. And you probably know about the inner core and the outer core. Well, it turns out there's a few ways to divide the Earth up. We can do it on their chemical composition, and we can also do it on their physical composition. So crust, mantle, core is sort of a difference in chemical composition. The crust has some of the lighter metal elements in compounds. The mantle is starting to get into some metallic and heavier things in compounds. The core is mostly iron, nickel, and a little bit of radioactive elements. Now, if we look at it from a more physical standpoint, we have the lithosphere, which is the crust and uppermost solid part of the mantle. So this part is very, very solid. It's rigid. This is the part we're familiar with. Then we have the asthenosphere, which is actually this taffy-like layer of molten rock that the lithosphere floats on and can move around on. And then, of course, the mantle includes the rest of those layers. Then we can also divide the core up into the inner and outer core, which is the liquid part and the solid part. So if we take a look at the next slide, okay, I define all these. So the crust, the upper rocky layer of Earth, you guys know the crust, and the mantle, the middle layers of Earth, and that's where we have the convection currents that drive plate tectonics. So remember, this is super incredibly hot in here, and so these particles, this heat rises, and as it rises through the mantle, it gets up to the asthenosphere. That layer cools and this sinks back down, and we have these convection currents, and that pushes the lithosphere around. And since the crust is floating or is attached to the lithosphere, the continents drift around. Not very fast, but it does happen. Okay. Then, of course, the core, the inner core and the outer core, and then the lithosphere and the asthenosphere. Now, what's actually making all this go? Well, in the core, there's radioactive decay, which means we have unstable elements that can break down into other more stable elements. And remember, if you went from unstable to stable, this releases energy. They have potential energy stored in them, but it's not chemical potential energy, it's nuclear energy. And so when this happens, we actually destroy just a little bit of matter and create a whole bunch of energy. This is the Earth's interior heat source. This is what makes the core hot. This is what keeps the core hot. And then because remember, hot particles are going to be in motion, they're going to collide with those other particles, and this is liquid, we get these convection currents that actually occur and drive things around. So in the mantle, we have these hot and cold convection currents going through, and then we have the plates on top sliding around and moving, and that causes earthquakes and volcanoes on the surface.